Yesterday we learned what to do with negative exponents. Our whole lesson yesterday was on negative exponents. Today we're going to figure out, one of the things we learned yesterday is we learned about negative exponents because we're not allowed to have negative exponents. We cannot have negative exponents. So there are a couple of other things that we can't have. A, we can't have any negative exponents. We can't have the same base. The same base does not appear more than once in a product or quotient. So we can't have a to the fourth, a to the second. We can't have that. That's a nope, 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 nope. We cannot have any powers that are raised to powers. So we can't have anything that's like a to the second to the third. We can't have that. So we're going to learn today what to do with this and this. What do we do when we see those? We can't have no products are raised to power. So we can't multiply two things and raise them to a power. We can't have that. So today we're going to learn how to not have that. No quotients raised to powers. We can't have a over b to the second. We can't have that. So today we're going to learn how not to have that. What do we do with that? And then numerical coefficients in a quotient do not have any common factor other than 1. So like on that one that you had for your homework, you had -3 over -6. We can't have that. Today we're going to learn how to do that. These are things that we can have. We can divide two variables and not have them raised to a power. That's fine. We can have this. That's just one variable to the third power or a different variable to another power. We can have products like this that are two different variables. We can have that. We can have quotients that are two different variables. And then we can have stuff like this where this has no common factor, 5 and a 2. There's not a number that goes into both of those. These are all okays. These are all not okays. You can't have an A here and an A there. We're going to learn how to get rid of that today. You can't have an X there and an X there and have them have different exponents or even the same exponent. Can't have that. Can't have a power to a power. We're going to figure out how to do something with that. You can't have products to a power, quotients to a power, or anything like this that has a common factor. Can't have any of that. All right? So we're going to learn what to do when we have it. First things first. This is the one example of what we're doing that is not in your foldable. So you can write it like at the bottom of your foldable or in your notes. You can do that. I don't care. But this is what we're going to do. And I want you just to watch this. If I have 3 to the 5th times 3 to the 2nd, essentially what I have is 3 times 3 times 3 times 3 times 3. Is that 5? 1, 2, 3, 4, 5. Yes. Then times 3 times 3. So when I take 3 to the 5th and multiply it by 3 to the 2nd, basically how many times am I multiplying 3? 7 times. That equals 3 to the 5 plus 2, which is 3 to the 7th. So what you want to write in your notes is a to the m times a to the n is equal to a to the m plus n. So when I've got the same variable and I'm multiplying them and they have different exponents, all I do is add the exponent. So this is in your notebook somewhere. So I'm going to give you about 2 examples, and then we're going to switch to our whiteboard, and you're going to practice, okay? So if I have, we just did that one. So if I have this one, write this down in your notes. In your notes. Again, this one's not in your foldable. This is the only type that we're learning that's not in your foldable. So in your notes, you're going to write 2 to the 4th times 3 to the 4th times 2 to the -2 times 3 to the 2nd. We're going to pick out which 2 different bases do I have. I have 2 there. They don't all have the same base, right? So what are my 2 different bases? 2's and then 3's. So anytime I see a 2, I'm going to add those exponents. What is 4 minus 2? 2. So that's going to equal 2 to the 2nd And then what is 4 plus 2 times 3 to the 6th? That's the answer to that. That is that simplified. Okay, we're going to, let's do another one. Do I have all the same base, or is there anything different? Different, yes. I have q to the 3rd, q to the 6th. So that's going to be 3 plus 6. What's my q going to be? Exponent's going to be 9 times r to the 2nd, because there were no other r's. Okay, get your whiteboards out. We'll practice a couple on our whiteboards, and then we'll go on to our foldable. And lucky the foldable has a lot of examples in it. Okay, here we go. On your whiteboard, write this. N to the 3rd times n to the negative 4 times n to the, there's no exponent there. So what's the exponent? 1, yes. And so essentially, all you're going to do is add the exponents. In a minute, when you have this done, I'm going to get you to hold up your whiteboards. If you're not finished, you hold up your whiteboards anyways. So, because if you're not finished, that's something that I need to know. Okay, hold your boards up. So everybody's holding up what they have on their whiteboard so I can see. If you're not done, Kaya, it is okay. I just need to know that you're not done. That's fine. This turns out to be 1, because what you end up with, when you add 3 minus 4, you get negative 1 plus the 1 here ends up being n to the 0, and anything to the 0 power is 1. Okay. Try this one. It's 3 to the negative 3rd times 5 to the 8th times 3 to the 4th times 5 to the 2nd. And you can't have the same base. So we're just going to add the exponents of each different base. When you're done, just leave it as 3 to the whatever. Don't give me an answer. Don't give me a number answer. I just want to see your bases and exponents. All right, hold your boards up. Let me see what you have. And you're going to end up with 3 times 5 to the 10th. Because negative 3 and then this 4 is just a 1. And then the 8 plus the 2 is 10. All right? Yes, let's try this one. This was the exact example I was looking for. We also, Jonah, want to go back and remember the things that we learned yesterday as well. So it's m to the 1st times n to the negative 4 times m to the 4th. So we're going to add the exponents on the m's. What is the exponent on the m's? 5. It's going to be 5. M to the 5th. What is the exponent on the n? Are we allowed to have a negative 4 exponent? So what it ends up being is this. And then you learned yesterday we can't have this. So the answer is going to be this. M to the 5th over n to the 4th. So we want to go back and add in the concept that we learned yesterday where we're not allowed to have negative exponents. Okay, let's try another one. Let's try this one. So all the same, this is all the same base. So all you're going to do is add the exponents. You're going to add 1 plus negative 1 plus negative 3 plus negative 4. Okay, hold your boards up. Let me see what you have. Now, are we allowed to have negative exponents? No. So you ended up with x to the negative 7. Well, actually, I wouldn't have done, here, let me just cover that up. You have, when you add all this up, you get 1 plus negative 1, which is 0, minus 3, which is negative 3, minus 4, which is negative 7. So you get x to the negative 7, but we're not allowed to have that. So we're going to have 1 over x to the 7. Boom. Okay, we'll do a few more. Not that one. Oh, actually, we'll stop on this one. Okay, now get your foldable out, and all the rest of the examples are going to be in our foldable. It's perfect. Okay, I just want you looking up here. So your foldable's out. Your foldable's out in front of you. Okay, I want you looking up here. This says, this is a power to a power, and basically this says take 4 to the third, or 4 cubed, and multiply it by itself 2 times. So this is 4 to the third times 4 to the third, yes? Well, what did we just learn to do with the exponents when we've got the same base? What did we just learn to do? Add them. So this is going to end up being 4 to the 3 plus 3, which is 4 to the 6th power. And so all I do is multiply that. So now, go to this page of your foldable. At the very front, it says a power to the power. And you'll see down there it says a to the m to the n. That is going to equal a to the m times n. You multiply. When you have powers to a power, you multiply the exponents. And so, flip your foldable up, and you're going to see this, and it says to raise a power to a power, keep the base and multiply the exponents. And we're going to do an example here of one that we just kind of did. 5 squared to the third power, and I wrote mine really tiny right here, is equal to 5 squared times 5 squared times 5 squared. What did we just learn to do with all the exponents? Add them together when we're multiplying them and they have the same base. So that's going to be equal to 5 to the 6th, or 5 to the 2 times 3. So we're just going to work some examples. And again, I'm so excited. I have them all in this foldable. It's perfect. Here we go. Right here, I skipped the, all right. So on this one, I have a power to the power. I have x to the third times 4. So we're just going to multiply these, and that's going to be x to the 12th. And so this next one's going to be, if I were to multiply that, it would be m to the 5th times m to the 5th times m to the 5th times m to the 5th, 7 times. And that would give me m multiplied by itself 35 times. Number 3, k to the 6th to the 8th. What is that going to be? K to the 48th. Number 4, a to the 9th to the 3rd. What is that going to be? A to the 27th. So when we have a power to a power, we just multiply the exponents. Now go flip your foldable back down. And power to a product. In other words, I'm doing a times b to the nth power. Well, all that means is I just distribute this n to everything in there. Everybody gets an n. Kind of like being on Oprah. You get an n, and you get an n, and you get an n. And so what that ends up being is a to the n times b to the n. Everybody gets an n that's inside the parentheses. So flip your foldable back up. And this says to raise a product to a power, raise both factors to the power and then multiply any exponents that you have. So we're going to do an example. What you can write down here is something really small, 8x to the third. You get a 3, and you get a 3. And what that means is a to the x times a to the x times a to the x. Well, that just means 8 cubed times x cubed, which is 8 cubed is 512, I hope, because that's what I'm writing down, times x to the third. You get a 3, and you get a 3, and you get a 3. Here we go. Let's practice some. So on this first one, it's in the parentheses, everybody gets a 7, and it turns out to be a power to a power. You get a 7, and you get a 7. And so now I have f to the what? 21, and g to the what? Yes. F to the 21, g to the 35. And then on number 6, you get a 3, and you get a 3, and you get a 3. Everybody gets a 3. And that leaves me with 4 to the third, which I'm telling you is 64. Then r to the second to the third, which is how many r's? 6. Then s to the 9 to the 3, which is 27. All right, 2 more. You get a 5, and you get a 5, and you get a 5. Everybody gets a 5. And 2 to the 5th is, anybody? 32. 2 times 2 times 2 times 2 times 2. I think I did it 5 times. Then e to the 4th to the 5th is e to the what? 20th. Then f to the 3rd to the 5th is what? F to the 15. Boom. Then, last one. You get a 2, and you get a 2, and you get a 2. Everybody gets a 2. That negative sign, is it in the parentheses? Yes. So it's -5 times -5. What is that? That is a positive 25. And then x to the 6 to the 2 is what? X to the 12. And y to the 1 to the 2 is what? Ooh, I didn't draw. Ooh, I didn't give. What? I don't even deserve. That's why I've never been on Oprah. I forgot to give that poor little y too. Shame on me. And then finally z to the what? 16. All right. And so the last thing we're going to do is we're going to raise a quotient to a power. Guess what? It's the same thing as being on Oprah. Where do you think that n goes? Everywhere. Everybody gets an n. A gets an n. B gets an n. And it ends up being a to the n over b to the n. And so what we're going to do is to raise a quotient to the power, raise the numerator and the denominator to the power, and then multiply the exponents. And so for my example here, I just have a over b. Let me rewrite that because I forgot I was recording. A over b to the n. Oh, let me just do a real one. Why do I always do this when I'm recording and then 5th period my lesson was amazing? Let's just do x squared over y squared to the 3rd power. That's going to be equal to x to the 6th over y to the 6th. Killed it. Made that up on the fly. I'm amazing. All right, and so we got a couple of examples to do, and they're just like everything else we've done. Number 9. You get a 6, and you get a 6, and that's so easy because it ends up being x to the 6th over y to the 6th. It's basically the same concept. You just make sure everybody gets what's outside the parentheses. You get a 2, and you get a 2, and you get a 2. What is 7 squared? 49. B squared over C squared. And number 11. You get a 3, you get a 3, you get a 3. What's 5 cubed? What's j to the 4th to the 3rd? Pause. Pause. Okay, then it was j to the 12th over k to the 21. All right, then you get a 4, you get a 4, and you get a 4. 3 to the 4th, what is that? 81. M to the 5th to the 4th. 20th. N to the 2nd to the 4th. N to the 8th. Okay, make sure your whiteboard is out. We're going to do a lot of examples. You may put your foldable in your notebook when we are finished. Dry erase stuff is out, and we are ready to go. Your first example is, I'm going to go with this. X to the 3rd to the negative 5. And then x to the 4th. So first multiply them out, and then see if you need to add, and then don't forget everything that you learned yesterday. Marker, where's my pen? In my pocket? Nope, it's right here. Oh, I put it on the board. What? Okay. I'm going to give you a little extra time on this one. It's our first one. All right, hold your boards up and let me see what you have. Okay, so this ends up being x to the negative 15 times x to the 4th. So I'm adding these exponents. What would I get if I added those? Negative 11 equals x to the negative 11, which is 1 over x to the 11th. All right, let's try another one. That was looking pretty good. Let's try this one. Okay, a to the 3rd to the 4th is a to the 12th, yes? A to the negative 2, negative 3rd is a to the positive 6. So at the end of the day, my answer is a to the 18th. All right, we already did that. Let's try this one. Watch where that negative sign is. Look, at the end of the day, is my answer going to be positive or negative? Negative, because that negative sign is just hanging out outside until the answer is there, and then you attach the negative. So this is a product to a power. So you get a 2, and you get a 2, and then you don't forget the negative. All right, hold your boards up and let me see what you have. If you have nothing, I need to know you have nothing. All right, and the answer is negative 4 because that's what 2 squared is, and y squared, then bring the negative sign down. All right, let's try this. All right, hold your boards up and let me see what you've got. A lot of different answers. This ends up being, everything gets a 2. So a to the 6 to the second, y to the negative 3 to the second. And at the end of the day, I get x to the 12 times y to the negative 6. Negative goes on bottom. Don't forget that your negatives go on bottom. We're not allowed to have negative exponents. Let's try this one. So first, just distribute the exponents that are outside each set of parentheses, and then look at what you have. Then you're just going to go to adding the exponents. You can even get rid of the parentheses when you're done passing out or distributing the exponents. That's what I would do. So you get a 4, and you get a 4, and you get a negative 4, and you get a negative 4. And then you have x to the 8th times y to the 12th times x to the negative 8 times y to the 16th. And then at this point, all you're doing is just adding exponents. What is 8 minus 8? 0. What is 12 plus 16? It's 12 minus 16. Why is it? Oh, because that's a negative, of course. So it's going to be y to the what? Negative 4, which is 1 over y to the 4th. Boom. All right. One more example. Let me pick a doozy. You can do this doozy. You're going to be good to go. Let's try this one. This is our last one. It's basically just the same thing. You're either multiplying the exponent if it's a power to a power, or adding the exponent if you're multiplying the same base. You get a negative 2. You get a negative 2. Raise your boards up and let me see what you have. All right.